Hello, today we're going to talk about problem solving with trigonometry. So the first thing that we are going to discuss are angles of elevation and angles of depression. So you need to understand that whenever you are looking up to an object, the angle of elevation is going to be formed by some person's line of sight and a horizontal line. So what I mean by a line of sight is if we look at this person here and we imagine their eyes looking up to the top of that lighthouse. The line of sight is that line that is highlighted. The way we naturally look, when we look at things, we normally look at things head on or straight ahead. So that is the horizontal line. So basically, your angle of elevation is the angle that is formed by you looking straight ahead and you looking up to something. Okay? So that's what the angle of elevation is. Similarly, when you have angles of depression, that happens when you are looking down at an object. You will have an angle of depression, and it is going to be formed by the angle that is made by a person's line of sight, meaning them looking down at something, and the line that is created when they're looking straight ahead. All right, so let's look at some examples. So, example one says a dog is standing 5 feet from the base of a tree. So, if I have a dog, I can just put this point here for dog, and it's standing 5 feet away from the base of a tree. So my tree is going to be this vertical line here, and this is going to be 5 feet. It says it's going to be looking up at a cat that has climbed 16 feet up the tree. So because the cat has climbed 16 feet up from the tree, I know that the cat is going to be up here. So we are trying to figure out what is the angle of elevation from the point that the dog is standing on the ground to the cat. So we're trying to find the angle that is created from the dog looking forward to the dog looking up at the cat. So we're trying to find this angle here. So we're going to call that theta. We already know the cat was 16 feet up the tree. So now we have enough to apply trigonometry, sine, cosine, and tangent. So the pieces that we are given here in relation to that angle is going to be the opposite and the adjacent, so we can use tangent. So here we're going to say the tangent of that angle is equal to the opposite, which is 16 over 5. And then we will need to do the inverse. So theta is going to be equal to the tangent inverse of 16 over 5. And if we put in our calculator, please make sure your calculator is in degree mode. If we do the tangent inverse of 16 over 5, we will end up getting that the angle of elevation is approximately 72.6 degrees. Example number 2, it says, a lifeguard is looking down at a swimmer. Okay, so if we draw it, we're going to have a lifeguard here, so I'm going to call it LG. So we have a lifeguard. The lifeguard looking straight ahead will have a line of sight like this, but it's looking down at a swimmer, so like this. So here's our swimmer. And then it says, if the lifeguard is 8 feet above the ground, so that means the lifeguard is 8 feet above the ground, it says and the angle of depression to the swimmer is 18 degrees. So my angle of depression is 18 degrees. It says how far away is the swimmer from the lifeguard. So how far away is the swimmer from the lifeguard? So they want to know this side here. And I'm going to call it X. All right. So if we look here from what I drew, if because it says that the lifeguard is 8 feet above the ground, I can also draw this line here, and I could put that as 8 feet. Anytime they say above the ground, they're talking about vertical distance. That way your picture will look a little pretty. And then they said here that we have an angle of depression of 18 degrees. So this is my triangle. So because I have this, the information that I have the angle, I have the opposite, and then I have the hypotenuse, of course, because this is a right angle here. Okay, and I need to draw my right angle in for the other triangle as well. We can use sine. So we're going to have that the sine of 18 is equal to the opposite, which is 8 over x. So the first thing that I'm going to do is multiply both sides by x. And then I'm going to divide by sine of 18. So when I do 18 divided by, 8 divided by sine of 18, I will end up with about 25.9. in 3 sig fig. And so that's going to be feet, of course. All right, so that's angle of elevation and angle of depression. Okay, let's look at example number 3. So it says, find the pitch of the roof theta. So one thing you should notice is that we are dealing with an isosceles triangle here. And the reason why you should know that is because we have an indentation here that I'm marking in green and then an indentation here. So because they have the same amount of what we call tick marks, that means that the other side over here is 9.2 centimeters as well. So another thing that you should know about an isosceles triangle is that if you draw the height in an isosceles triangle, it is going to bisect the base and it is going to divide the base in half. That's what bisect means. So if I draw my height in, I understand that it's cutting this base in half. So the total length of this base, if I add up the 2, the 13, and the 2 on the other side, the total length is 17. And if I divide that by 2, that gives me 8.5. So I know that from the left side to the middle is 8.5. So now I have enough information for my angle theta here. In my angle theta, I know that if I look at that angle theta, the size that I'm given is the adjacent side and the hypotenuse. So that means I'm going to use cosine. So I'm going to say that the cosine of angle theta is equal to your adjacent, which is 8.5, over your hypotenuse, which is 9.2. And I know that the theta is going to be equal to the cosine inverse of that fraction. And when you put that into the calculator, you are going to end up getting that your angle is approximately 22.5 degrees. Okay, that is your angle, 22.5 degrees. All right, so now let's look at the last example, example number 4. So example number 4, we have a prism here. So it says calculate the length of the longest rod that will fit inside the box. So I'm going to draw that longest rod in. So you should know that the longest rod is going to be the length that is going from one corner to the opposite corner on the other side. So for instance, let's say if I start and I put the rod inside of corner P. the length of the longest rod will need to extend to corner B. So if I draw my line here, that is my line, and then I know I can create another line to go here to this corner R, and then I will have that as my height. So basically, I need to use the Pythagorean theorem to figure out this information. So the first thing that I'm going to find here using the Pythagorean theorem is this triangle here on the bottom. That's a right triangle because I already know in that box here that's 90 degrees. So we already know that we have a squared plus b squared is equal to c squared. So I'm going to have 9 squared plus 5 squared is equal to c squared. And I know that if I take the square root of 9 squared plus 5 squared, it's going to give me c. So I can say here that c is approximately 10.3. So I'm going to write that in down here that this is 10.3. All right. So now that I know that that part is 10.3, I can now use what I have to figure out the length of the longest rod now, because now I have everything inside of that red right triangle there. So I'm going to use Pythagorean theorem again. So if I calculate that longest rod here, that means I'm going to have 10.3 squared plus 4 squared is equal to c squared. So of course, if I take the square root of 10.3 squared plus 4 squared, I will end up with 11.0 in 3 fig, or just 11, and that is going to be approximately c, and that is the value that I want. That'll be the length of PV. So I know that PV is approximately 11. So that will be my answer there. If you have any questions on using trigonometry to solve questions, please let me know, and have a great day.